All right. I think probably many of you guys have heard the word odds used interchangeably with probability. And actually, odds is different than probability. The odds uses probability in its calculation. I guess I should try and spell this correctly. Talking and writing sometimes don't always work together. So it's different than probability. But we have to know the theoretical probability first so that we can calculate the odds. So the odds are dependent on the probability. So the odds, the calculation for odds is it's the ratio between the probability of the event happening versus the probability that the event doesn't happen. So generally odds is something that we talk a lot about in terms of gambling. And odds generally refers to how much somebody is going to win or gain. Um, so a lot of times odds is based on money, based on gambling. So let's look at an example. So what are the odds for rolling a 2 or a 5 with 2 dice? Okay, so we want to calculate the odds for rolling a 2 or a 5 with 2 dice. So, so the probability for rolling the 2 or the 5s is 2 out of 6. So there's 2 opportunities out of a dice of 6. So the probability of not rolling a 2 or a 5 is 4 out of 6. It's what's left over. Again, these add up to 1 out of 1 or 6 over 6. Okay, so now we want to write it as a ratio. And so because the denominators are the same, so the odds, the denominators are the same, so we can ignore the denominators and we're just matching numerators now, are 2 to 1, 2 to 4. Generally, the odds are simplified, so most commonly you would say 1 to 2 odds. In terms of how this relates to, say, gambling or winning, for every dollar that you spend, and if it happens, if you get 2 or a 5, you will win $2. So for every dollar that you bet, you would win $2 if a 2 or a 5 show up. And then it's a flip side if you're talking about the house. So it just depends on whether it's the odds for you or the odds for the gambling establishment or what we call the house. All right, so just know that odds is very different than probability. It depends on the probability. It is not probability, although people try and use those words interchangeably all the time. So now let's look at some tables here. So we've looked at some tables already. So let's look at tables in terms of probability. We've actually done this a little bit, but we haven't talked about the ands and the ors so much. So the probability of female. So if we look at the probability of female, so we're looking at the total number of female out of the total. So we would have, this would equal 1,000 or 18,312 over the total, which is 27,268. If we're looking at the probability of 1 or 2 drinks, this time we're going to read across. So we end up with 5,825 over the total, which is again 27,268. Now the last one here is an AND probability. And keep in mind with AND probabilities, we had this idea of multiplication. But when we're reading the tables, we're looking for the overlap. Okay, we're looking for whether it's a Venn diagram because it's this and this. So these two things are happening at the same time, which means that that is what we're looking for, the overlap of 3 and 4 drinks, and they're male. So male, 3 and 4 drinks. So this probability is going to be 912 out of the total 27,268. So similarly, we have a bigger table here. This time, let's see, we have just what's the probability of a psychiatrist. So we're going to read all the way over. We have 118 psychiatrists out of a total of 206 or 600, excuse me, 635. Oh, a left-handed dentist. So this is actually an AND probability again, because we have left-handed and there being a dentist. Remember that the word "and" can be implied. And so we want a left-handed dentist, so there's 10 of these people out of the total, so 10 out of 635. And now for the last one, we have an OR probability. We have an OR probability, so a lawyer or somebody that's right-handed. So we have all the lawyers. We need all the right-handed people, but we noticed that we counted the 83 in the lawyer line, in the lawyer row, and in the right-handed column. So what we really want to do is, so we're going to so we have 105 lawyers. I'm going to put it underneath. 105 out of 635. Again, an OR statement is we add. We have a total of 536 right-handed people, 600 out of 635, but we overcounted 83 of them. And so that would be how we would set up this problem to figure out what the actual probability is. Remember, you want to show your setup so that you know that you're on the right track. The rest of this is just a calculation of by just going into your calculator and adding up each one of these and subtracting out the 83 to give you the fact that we're going to have 558 out of 635 lawyers or right-handed.